Hi, Year 12. This video relates to 1B and we're looking at arithmetic sequences. They're also called arithmetic progressions, so we often refer to these as APs, and you'll get the hang of that as we go through because we look at other things relating to progressions as well. So an arithmetic sequence is a sequence that has a constant difference between the successive terms. So basically we're adding or subtracting an amount to get that next term. For example, in this sequence here, we're adding 10 to move along. In the next one, we're taking 1 off, and the last one, we're adding 4. So these would all be examples of arithmetic sequences, and you need to know whether one is or not, because we're going to have a look at ones in a moment, probably next lesson, that are geometric, that we're not adding or subtracting, but we're multiplying or dividing. So if it is an arithmetic progression, and I'm going to call them APs, we've got different formulas that we need. But we do not need to memorize these formulas as they are on our HSC formula sheet. So I might jump over to that sheet now and show you where they are. So on the first page of our reference sheet in the section called Sequences and Series, there's a whole heap of formulas here, and that relates to the topic that we're currently doing. And you might see that there is our first one that we're going to have a look at in a minute up there. The different formulas that we're going to use are not going to be able to be used for every kind of sequence. So the formula that we've got here is only for an AP, or an arithmetic progression. And it's saying that Tn is equal to A plus n minus 1 times D. A is your first term, and D is the difference between the successive terms, or one term to the next. So we can test whether or not we have an AP, and that's what we're going to do down here. Example 1 says to test whether each sequence is an AP, arithmetic. If the sequence is an AP, find its first term and its common difference, D. So to test whether it is an AP, we want to decide and test whether or not the difference between the first and the second term, or two successive terms, is the same as the next two. So we need to look that it happens more than once, and that they're the same, and then we can assume that it's going to follow on and be the same for all of them. If you just test it for two particular terms and not test it again, then it may not apply for all of those values in that sequence. So let's have a look at doing term 2 minus term 1, which is 43, minus 46, which is minus 3. Then let's have a look at the next two terms, which would be term 3 minus by term 2, which is 40, minus 43, which is also minus 3. So we've got that consistency. It's happening more than once, this difference between the terms. So we're going to assume that it is an AP. So we're testing whether it is. It is. We want to find the first term. So the first term is 46. That's fairly straightforward. 6 0 is 46. And our difference between the terms is minus 3. So let's test it. The next one is an AP. So we're going to go term 2 minus by term 1, which is 4 minus by 1, which is 3. Then let's go term 3 minus term 2, which is 9 minus 4, which is 5. There is a consistency in there. This is not an AP. And it's as easy as that on a simple sequence to test whether or not it's an AP or not. Okay, let's have a look at the next one. Let's write out the first 5 terms and then calculate the 20th term of the AP with. A is 2, so remember A is our first term. Actually, we don't need to write that down like that. And our difference between the terms is 5. So we're increasing by 5 to get our next term, and we're increasing by 5 along and along and along until we calculate our first 5 terms. Okay, so there are my first 5 terms calculated there. Now, it wants to calculate the 20th term. Now, it is going to take too long to keep adding 5 along, because they could ask us in a question to calculate the 100th term, in which case we are not going to go term by term, but there's a formula up there. We've said that this is an AP, and the formula for the nth term is this one here. So term n is A plus n minus 1D. So let's pop that formula down. A plus n minus 1D. We have A and we have D. So we want to find term 20. Term 20 would be 2 plus n minus 1, which is going to be 19, times by 5. So term 20 is going to be 2 plus 19 times 5. So term 20 is going to be 97. Let's have a look at B. We want to find the 20th term when our AP starts with A and our common difference is minus 3. So we're going to be getting smaller this time. So we're starting with 20 and we're taking off 3 each time. Okay, there's our first 5 terms. We want to find term 20. Term 20 is A plus n minus 1d, which is 20 plus, I'm going to just put 19 in there this time, times minus 3. The term 20 is minus 37. Okay, so we want to find a formula for the nth term of this sequence. So we're decreasing in size. We've got our first term being 26, and at this point, we don't know if it's going to be an AP, so let's just test it. Let's go. Term 2 minus by term 1, 35 minus by 26, and what you're going to end up with is 9. Let's test term 3 minus by term 2, which is 44 minus 35, and 44 minus 35 is also 9. So in this case, our common difference is 9, and it's an AP. So we want to find a formula for the nth term. So since we know it's an AP, we can use the formula above that the term n is going to be A plus n minus 1 times d. So our nth term is going to be 26 plus n minus 1 times by 9. And we can expand that out and neaten it up. So term n is 26 plus 9n minus 9. We can neaten that up a little bit further. So what we're going to end up with is term n is going to be 26, or not 26, sorry. And so that was 17. 17 plus 9n. Okay, so we can now find some other information about sequences using our formula above. So I've got a sequence here, sorry, and there's a few missing numbers in the middle, but we know that our nth term, which we don't know what that is yet, what term that is, but term n is 917. Our first term is 26, but let's just see what our common difference is. I'm going to do a test and write it a little bit differently. So we can go term 3 minus by term 2. Does that equal term 2 minus by term 1? So let's show that. So we're going to have 44 minus 35, which does that equal 35 minus 26. 44 minus by 35 is going to be 9. 35 minus by 26 is also going to be 9. So that's our common difference. It's another way of writing it. Okay, we want to find what n is, because we know that term n is going to be 917. So using our formula, A plus n minus 1d, 917 is going to be our first term, which is 26, plus n minus 1 times by 9. Let's expand that out. 917 equals 26 plus 9n minus 9. Let's gather like terms. 917 is 26 minus 9, which is 17 plus 9n. Let's take 17 from both sides. So 900 is 9n. N is going to be 900 divided by 9. N is 100. So there are, I'm going to write a sentence there. There are 100 terms in this sequence. Okay, question number 4. Find the formula and the first negative term in this sequence here. Okay, so we need to again confirm that it is an AP. We know that our first term is 200. Let's look for a common difference. Let's see that 186 minus 193. Actually, let's write out with terms first. Term 3 minus by term 2 equals term 2 minus term 1. So let's just formalize it and write it down like that. That 186 minus 193 is equal to 193 minus by 200. So popping that in your calculator, double check that we've got minus 7 on the left and we've got minus 7 on the right. So what we have is our common difference is going to be minus 7. So we want to find the first negative term. So we want to find the first term that is less than 0. we don't want it equal to 0 because we want negative. So negative would mean it's going to be less than 0. So we find that our formula is a plus n minus 1d. We want to find our t to the n, which is 200 plus n minus 1 times minus 7, where that is going to be less than 0. Okay, now I need to neaten up my term n. So let's multiply by minus 7. Remember, that's a times in there. So it's going to be 200 minus 7n plus 7 is less than 0. So 207 minus 7n is less than 0. So let's solve that. I'm going to take 207 from both sides. So I get 7n is going to be less than minus 207. I'm going to have to divide by the minus 7, which is going to flip my sign over the other direction. Dividing that will give me that n is going to have to be greater than 29.5714. There's a few numbers after that. What's the first number that's bigger than, whole number bigger than that? N is going to have to be greater than 30. So the first negative term is the 30th term. And I've written that as a sentence over to the side here.